This is Paul Anderson again with another video tutorial on video analysis, and this time again we're using Tracker. So I'm going to go ahead and open up my new video, and this time we are looking at some elastic potential energy versus kinetic energy. So you can see that I've got a nice video here of my son, and he's got his bow and arrow drawn back. We're going to queue up our video, and then again, this point in time, we want to kind of cue it to the area where he is got the excuse me, the bow drawn and has not quite released it yet. Okay, and so we'll set our tab mark there, and then we'll watch it again. And we really only have to go until we see the arrow leave the end. And I'll back it up one. There we go. Set my tab stop again. So now my video should be good in between this range, so we watch the arrow go. And again, what we're looking for is we're looking at the elastic potential energy drawn back here, changing into kinetic energy here. And we may be able to look at kind of that force that was applied. So we'll look at like elastic force versus the net force, or as the net force. So we're going to have two different routes that we can look at with this one. So we need to go ahead and start plotting our points. I'm not going to actually do the auto track on this one. I'm just going to plot the points themselves manually. And I think I just hold the shift key down and tap it to give my points. And it's just I don't have a lot of points, and I don't have a nice clear background either, so I really do have to kind of target my points based on what I see. So the auto track feature won't work very well here. This video was taken at about 80 frames a second, so we'll be able to kind of again look at this under some adjustment. And so that's my last frame. I'm going to go back to my movie clip, and I'm going to reset this to be 80 frames a second, say OK. And now I can again set this so that my origin is going to be in a good spot. Let's go ahead and advance a couple so I know where I want my origin to be. And this time I'm going to bring my origin down and line it right up on that center point and kind of skew it so that we have our X direction in line with our arrow. Like that. So most of my points look like they line up fairly well there, and that's a good thing. The last thing that I need to do again is I need to set a scale, so I'm going to grab a new calibration stick, and I'm going to place it on one end of the bow, down here to the other, and this distance is going to be 0.75 meters. And there we go. We now have that set. So we've got our scale set, we've got our origin set, we've got our points plotted. We can look quick at our graph. So in the X direction we see some stuff. It looks kind of noisy on the Y direction, but that's okay. So again, it kind of looks like a nice little curve here. And we get our straightaway here. This is where we have our kinetic energy. The last thing I'm going to do here is I'm going to try to do a measuring a distance. Okay. so I'm going to go from where his hand is to where the equilibrium position is on here. And so this is going to measure my distance that he's drawn this back. And we have it about 0.3, it looks like. Okay, so it looks like he's pulled it back about 31 centimeters. So that's the distance that I'm going to use in that calculation for the elastic potential energy. So now I've got my distance measured, I've got my speed measured up here. We can now go back here to our analyze. Okay. And I'm going to select these points out here, and I'm going to do a quick little look for a curve fit. We want it to be aligned, so in other words, now I know my speed. If I know my speed, I know the mass of the arrow, I can then find my kinetic energy, and my kinetic energy is equal to that elastic potential energy, so I should be able to figure out what my spring constant is for my elastic band. Now, how would I do this for the other set, or in a different way? I could look at this range of data and then readjust this to be a curve fit. So let's give this a parabolic fit. Now this parabolic fit should give me some different values. Again, that A coefficient should be relative to half of the acceleration. So I can look at that to figure out what my net force is. My net force is now equal to my elastic force, or my Kx, and so I could then plug that in to find the K value as well. The two K values should show up the same either way that we look at it. So hopefully that gives you another idea of how to use video analysis, and we can use Tracker to do something like that. We'll see you in the next tutorial.